Hello everyone, my name is Pranit Balaram Dhotre and I am 4th year student of ISER Mohali. My course is Solid State Physics, which is Physics 402, and the instructor of this course is Dr. Gautam Sheet. Today the topic of my presentation is organic semiconductors. What I am going to talk about is this. I am going to talk about the history, the definition, brief description about it, applications, and result. Talking about the history, initially in 1862, Henry Letheby found a partially conductive material by oxidation of aniline in H2SO4, and that material was polyaniline, or we can call it ani. After, in 1950, scientists discovered that polycyclic aromatic compounds, which form charge transfer complex salts with halogen. In 1954, high conductivity of 0.12 Siemens per centimeter was found in perilene iodine complex, and this indicated that organic compounds could carry charge. The definition is that organic semiconductors are conjugated organic polymer materials having very high conductivity. We have known from our previous knowledge of chemistry that conjugate organic polymers are polymers with alternate single and double bond in their end-to-end structures. The conductivity can be explained on the basis of energy gap, and this material have intrinsic semiconductivity with energy gap of about 1 to 2 electron volt. And the polymers are mostly insulators, but because of this double bond, they can carry charge. These conjugate organic polymers can be found in two forms, polyacetylene and polyphenylene. As you can see, there are two types of organic semiconductors, intrinsic semiconductors and extrinsic semiconductors. Where intrinsic semiconductors are pure semiconductors, or we can call it undoped semiconductors. In intrinsic semiconductors, number of holes and number of excited electrons are equal. Talking about extrinsic semiconductors, they are called as impure semiconductors or doped semiconductors. These extrinsic semiconductors have further two subcategories called as p-type semiconductors and n-type semiconductors. An extrinsic semiconductor called as n-type if it is doped with electron donor atom, as the majority of charge carriers are negative electrons in the crystal. And if the intrinsic semiconductor has been doped with electron acceptor atom, then it is called p-type semiconductor, as the majority of charge carriers are positive holes in the crystal. So these p-type semiconductors and extrinsic semiconductors are doped with electron acceptor atom, where n-type semiconductors are doped with electron donor atoms. In p-type semiconductors, an electron acceptor, which is an oxidant or a halogen, is added to organic polymer so that the electron from the conjugate polymer is extracted and cation radical is formed in the polymer. As you can see, the above figure is showing that. And the oxidant is added at the point of negative charge, and it forms a cation in the polymer, and which is called as polaron. As number of oxidant, which are electron acceptors, increases, polaron number also increases by breaking conjugate double bonds. Now low doping gives a polaron, but high doping gives bipolaron. That cation will travel from one end to another because of conjugate double bond, and as a result, charge is carried. The application of organic semiconductors are used in OLED, which is organic light emitting diodes, which is useful for displays and lighting applications. Electronic papers, it is used in thin film batteries, supercapacitors, organic photovoltaics, and sensors and biosensors. So it has a wide range of applications. So result, what we have learned, there are types of semiconductors, P types and N types, where P types semiconductors can carry charge as well as N types can carry charge. We have seen the polaron formation and the applications of organic semiconductors. These are the references I've used. Thank you so much.